So first problem based on the iterative method, successive approximation method, right? Solve g of s is equal to f of s plus lambda integral 0 to 1 e power s minus t g of t dt. So given equation, g of s is equal to f of s plus lambda integral 0 to 1 e power s minus t g of t dt, that is equation number 1. Here the kernel k of s comma t is equal to e power s minus t. So we know k1 of s comma t is equal to k of s comma t, and k2 of s comma t is equal to integral k of s comma t into k of t comma x dx, right, from the theorem, previous theorem, right? Here k1 of s comma t, which is equal to k of s comma t, which is equal to e power s minus t. So we are taking the main part of the theorem as a formula. So we are using that line and substituting the values according to this problem, and we will find the solution. That is the method. So that is why we are taking k1 of s comma t, k2 of s comma t. So k1 of s comma t is k of s comma t, that is equal to e power s minus t. So k2 of s comma t is equal to integral k of s comma x, k of x comma t dx, that is equal to integral 0 to 1. So replace t by x, right? So you will get e power s minus x. Similarly replace s by x, so you will get e power x minus t dx, that is equal to integral 0 to 1. So adding the powers, e power s minus x plus x minus t, minus x plus x get cancelled, so remaining you will get e power s minus t dx. So taking e power s minus t outside the integral, because the integration is with respect to x. So 0 to 1 integral dx, so e power s minus t x, right? The integral of dx is x, lower limit 0, upper limit 1. So you will get e power s minus t. Proceeding like this, we will get km s comma t, which is equal to e power s minus t. For all the things you will get e power s minus t only, right? So we know the resolvent kernel gamma s comma t is to lambda, which is equal to summation m is equal to 1 to infinite lambda power m minus 1 km of s comma t. So substituting the value of km of s comma t, summation m is equal to 1 to infinite lambda power m minus 1 e power s minus t. So taking e power s minus t outside, because there is no m in that, right? That is why we are taking outside the summation. E power s minus t, summation m is equal to 1 to infinite lambda power m minus 1. So substituting the values of m in the summation, you will get e power s minus t 1 plus lambda square plus etc etc. That is nothing but 1 minus lambda whole power minus 1. We know 1 plus x square expansion, right? That is equal to 1 minus x power minus 1, right? E power s minus t 1 minus lambda power minus 1. So gamma s comma t colon lambda, which is equal to e power s minus t into 1 minus lambda power minus 1. Clearly the resolvent kernel is analytical function of lambda, is an analytical function. Analytical function is differentiable, right? And it is regular for all values of lambda except lambda is equal to 1. So when you are putting lambda is equal to 1, so it will become infinite, right? Because 1 minus lambda power minus 1, that is equal to 1 by 1 minus lambda. When lambda is equal to 1, 1 by 0, that is infinite. It is not exist. So except that it will be differentiable. That is the regular. That is what, right? Also lambda is equal to 1 is the simple pole of the resolvent kernel, right? When lambda is equal to 1, you will get the simple pole, right? When a function 1 by 1 minus x tends to infinite, at what point that means that point is a simple pole, that is the pole, right? So when x is equal to 1, so 1 by 1 minus 1, that is 1 by 0, tends to infinite, right? So at x is equal to 1, the whole function tends to infinite. So that is the pole. Similarly here, instead of x you are having lambda. So 1 by 1 minus lambda tends to infinite, that is value is infinite when lambda is equal to 1. So lambda is equal to 1 is the pole. Power is 1, right? Lambda is equal to 1. So that is called, it is simple pole, right? So we know that the solution of 1 is given by g of s is equal to f of s plus integral gamma s comma t colon lambda f of t dt. So therefore the solution is g of s is equal to f of s plus integral 0 to 1, substituting the value of gamma e power s minus t 1 minus lambda power minus 1 f of t dt. Next problem. Solve the integral equation g of s is equal to 1 plus lambda integral 0 to 1 minus 3 st g of t dt by using iteration method, and also find the resolvent kernel. So we know that initial approximation 0 order, right? G f of s, that is equal to 1 here, right? G naught of s is equal to f of s, right? Here f of s is 1, therefore g naught of s is equal to 1. That is equation number 1. The first order approximation is, then 0th order we already found, that is first equation. Now g1 of s first order, that is equal to 1 plus lambda integral 0 to 1 minus 3 st. We have to use g instead of g of t, we have to use g naught of t, right? So dt, that is equal to 1 plus lambda into integral 0 to 1 minus 3 st g naught of t from 1, that is 1 value, right? So dt, right, that is 1 plus lambda integral 0 to 1, separating into two integral. First one 1 into dt minus 3 s lambda, both are constant, 3 constant, s constant, lambda constant, take it outside from the integral, minus 3 s lambda integral 0 to 1 t dt. So integrating 1 plus lambda t, lower limit 0, upper limit 1, minus 3 s lambda, integrating t with respect to dt, so t square by 2, lower limit 0, upper limit 1. Substituting the upper limit, so you will get 1 plus lambda minus 3 s lambda by 2. So because when you are applying the lower limit, it value is 0, right? So g1 of s is equal to 1 plus lambda into 1 minus 3s by 2. That is equation number 2. The second order approximation, right? Next, g2 of s, that is equal to 1 plus lambda integral 0 to 1 minus 3 st. We have to use g1 of t, right? Because we are finding g2 of s, right? That is what it is, iteration method, right? Successive approximation, g1 of t dt. So the 1 plus lambda integral 0 to 1 minus 3 st into 1 plus lambda into 1 minus 3t by 2 dt, right? So 1 plus lambda integral 0 to 1, split it into separate integrals, dt plus lambda square integral 0 to 1 minus 3t by 2 dt minus 3s lambda integral 0 to 1 t dt minus 3s lambda square integral 0 to 1 t into 1 minus 3t by 2 dt. That is equal to 1 plus lambda, integral dt is t, lower limit 0, upper limit 1, lambda square integral, again we are splitting into separate integrals, dt minus 3 lambda square by 2 integral 0 to 1 t dt minus 3 s lambda, derivative integration of t is t square by 2, lower limit 0, upper limit 1. Then again we are splitting into two integrals, minus 3 lambda square integral 0 to 1 t dt plus 9s lambda square by 2 integral 0 to 1 t square dt. So 1 plus lambda square, right? So integral 0 to 1 dt is t only, so you will get again 1 only, 1 into lambda square minus 3 lambda square by 2, integral of t dt is t square by 2, lower limit 0, upper limit 1. Then minus 3 lambda, substituting the upper limit 1 by 2, right? Lower limit 0, so you will get only one term, minus 3s lambda 1 by 2 minus 3s lambda square, integral t dt is t square by 2, lower limit 0, upper limit 1. Then last term plus 9s lambda square by 2, integral t square is t cube by 3, lower limit 0, upper limit 1. Substituting the upper limit, you will get 1 plus lambda square minus 3 lambda square by 2 into 2 4, minus 3s lambda by 2 minus 3s lambda square by 2 plus 3s lambda square by 2. So 3s lambda square minus 3s lambda square by 2, 3s lambda square by 2 get cancelled. So remaining 1 plus lambda square minus 3 lambda square by 4. So 4 minus 3, you will get lambda, right? Lambda square by 4. we are taking LCM, grouping lambda square term. Then minus 3s lambda by 2. So therefore G2 of S is equal to 1 plus lambda, taking lambda outside from first term and the last term, fourth term, right? So 1 minus 3s lambda, 3s by 2 plus lambda square by 4. That is equation number 3. Third approximation is G3 of S is equal to 1 plus lambda integral 0 to 1 minus 3st G2 of t dt. So substituting the value of G2 of t, you will get 1 plus lambda integral 0 to 1 minus 3st plus into 1 minus 3st into 1 plus lambda into 1 minus 3t by 2 plus lambda square by 4 dt, right? So that is equal to 1 plus lambda into integral 0 to 1 plus lambda into 1 minus 3t by 2 plus lambda square by 4 minus into dt minus 3s lambda integral 0 to 1 t, right? So we are substituting that values and separating, right? So etc., which is equal to 1 plus lambda into integral 0 to 1 dt, first integral, multiplying dt into 1 plus lambda into lambda square integral 0 to 1 minus 3t by 2 dt. Then last term lambda into lambda square, lambda cube by 4 integral 0 to 1 dt minus 3s lambda t into 1, right? So integral 0 to 1 t dt minus 3 lambda square, right? Lambda into lambda square integral 0 to 1 t into 1 minus 3t by 2. In the previous step you are having t into 1 minus 3t by 2 lambda into 1 minus 3t by 2, right? We are separating all these things. Then last term minus 3s lambda cube, right? Lambda square into lambda, right? So 3s lambda cube by 4, lambda square by 4, right? Integral 0 to 1 t dt. So that is equal to 1 plus lambda. So the integral of dt t 0 to 1, lower limit 1, 0, upper limit 1 plus lambda square. Again we are separating, right? 1 minus 3t by 2. So integral 1 into dt. So dt, integral dt is t, lower limit 0, upper limit 1 minus 3 lambda square, then by 2 into 2 by 2 into integral of t dt t square by 2, that is why 4, right? Lower limit 0, upper limit 1. Then lambda cube by 4, integral dt is t, lower limit 0, upper limit 1. Next 1 minus 3s lambda integral t dt is t square by 2, lower limit 0, upper limit 1 minus 3s lambda square. So again we are separating this one, t dt t square by 2, right? So minus 3s lambda square t square by 2, 0 to 1, lower limit 0, upper limit 1. Then minus 3s lambda square into minus 3 by 2. So 3 3s are 9, minus into minus plus. So 9s lambda square by 2 integral t dt, right? Therefore you will get t into t square, right? So already 1 t is outside, right? So t into t integral 0 to 1 t square dt. Then last one minus 3s lambda cube by 4 integral t dt is t square by 2, lower limit 0, upper limit 1. So substituting the limits we will get 1 plus lambda square minus 3 lambda square by 4 plus lambda cube by 4 minus 3s lambda by 2 minus 3s lambda square by 2 plus integral t square dt is t cube by 3, 9s lambda square by 2 t cube by 3, lower limit 0, upper limit 1 minus 3s lambda cube by 8. 1 plus lambda square by 4 plus lambda cube by 4 minus 3s lambda by 2 minus 3s lambda square by 2 plus 9s lambda square by 6 minus 3s lambda cube by 8. So grouping the terms, 1 plus lambda square by 4 plus lambda cube by 4 minus 3s lambda by 2 minus 3s lambda square by 2, then 9 by 6, it can be written as 3 by 2, 3 lambda square minus 3s lambda cube by 8. That is equal to 1 plus lambda square by 4 minus 3s lambda by 2, remaining that term, that is minus 3 lambda square by 2 plus 3 lambda square by 2 get cancelled. So minus 3 s lambda cube by 8. So G2 of s is equal to 1 plus lambda into grouping lambda term 1 minus 3s by 2, then lambda square term plus lambda square by 4, then lambda cube by 4 term plus lambda cube by 4 into 1 minus 3s by 2. Right? Now g of s is equal to summation n is equal to 1 to infinite gn of s. Right? So substituting the values 1 plus 1 minus 3s by 2 lambda, because we know g0, g1, g2 plus lambda square by 4 plus lambda cube by 4 minus 1 minus 3 lambda cube by 4 into 1 minus 3s by 2 plus lambda power 4 by 16 plus etc. etc. Right? So that is equal to 1 plus lambda square by 4 multiplying with that, right? Plus we are grouping the 1 plus lambda square by individual terms in the above. One second term and third term you are taking, right? Then leaving the fourth term, fifth term, right? 1 plus lambda square by 4 plus lambda power 4 by 16 plus etc. etc. We are grouping that one. Then the bracket terms 1 minus 3s by 2 into lambda, then that is even term, then odd term, odd power of lambda, even power of lambda, 1 minus 3s by 2 lambda plus 1 minus 3s by 2 into lambda cube by 4 plus etc. etc. That is equal to 1 plus lambda square by 4 plus lambda power 4 by 16 plus etc. etc. all even powers of lambda, then odd powers of lambda. Taking 1 minus 3s by 2 common, take it outside from these two terms. Lambda also common, take it outside. Lambda into 1 minus 3s by 2 into 1 plus lambda square by 4 plus lambda power 4 by 16 plus etc. etc. So here both in the both term 1 plus lambda square by 4 even powers are same, right? Take it outside. 1 plus lambda square by 4 plus lambda power 4 by 16 plus etc. etc. into 1 plus lambda into 1 minus 3s by 2. That is equal to 1 plus lambda by 2 the whole square, lambda by 2 whole square the whole square plus etc. etc. into 1 plus lambda into 1 minus 3s by 2. That is equation number 3. The sum of the infinite geometric series. This is the sum geometric series 1 plus lambda by 2 square 1 plus 1 by lambda by 2 square the whole square, 1 plus x is x plus x square plus etc. etc. geometric series we are taking. Here x is nothing but lambda by 2 whole square, right? So is 1 minus, that is 1 minus x whole power minus 1, we know, right? The formula 1 minus lambda by 2 whole square minus x, that is 1 minus x whole power minus 1. X is lambda by 2 the whole square. That is equation number 4. And the geometric series is convergent if only if mod x is less than 1, that is modulus of lambda by 2 square is less than 1. So that is modulus lambda square by 4 is less than 1. So lambda square modulus lambda square is less than, just to do the cross multiplication, less than 4. That is lambda is less than mod lambda is less than 2. The condition for convergence is mod lambda is less than 2. From 3 and 4 the solution is g of s is equal to, so substituting the values, so you will get 1 minus lambda square by 4 power minus 1 into 1 plus lambda into 2 minus 3s by 2. That is taking LCM and grouping 2 plus lambda into 2 minus 3s by 2, right? So 1 minus lambda square by 4 power minus 1, it will go to the denominator. 4 taking LCM 4 minus L square by 4. So 2 into 2 plus lambda into 2 minus 3s by 4 minus lambda square, right? That is the solution. Next we are going to find the resolvent kernel. We know resolvent kernel gamma s comma t colon lambda is equal to summation m is equal to 1 to infinite lambda power m minus 1 km of s comma t, kn of s comma t which is equal to k of st which is equal to 1 minus 3 st, k2 of s comma t which is equal to integral k of s comma x k of x comma t dx, that is equal to integral 0 to 1 minus 3 sx into 1 minus 3 xt dx, that is equal to integral 0 to 1 minus 3 xt minus 3 sx plus 9 st x square dx. So integrating with respect to x, so first term x, second term minus 3x square t by 2, third term minus 3s x square by 2 plus 9s t x cube by 3. So lower limit 0, upper limit 1. So 1 minus 3t by 2 minus 3s by 2 plus 3st. So k2 of st is equal to 1 minus 3 by 2 t plus s plus 3st. So k3 of st is equal to integral k s comma x k2 of x comma t dt, that is equal to integral 0 to 1 minus 3sx into 1 minus 3 by 2 t plus x plus 3xt into dx. So substituting the value of k2 of s comma t, s instead of x we are putting x, right? So replace according to that, right? So that is equal to integral 0 to 1 minus 3 by 2 t plus x plus 3xt dx minus 3s integral 0 to 1 x into 1 minus 3 by 2 t plus x plus 3xt dx. So separating all the things into individual integrals, then integrate. So 3x minus 3 by 2 tx minus 3 by 2 x square by 2 plus 3x square t by 2, lower limit 0, upper limit 1. Similarly in the second one, minus 3s x square by 2 after integration, right? So you have to separate everything into individual integral, then you integrate, you will get these terms, right? I am skipping those terms, right? Minus 3s x square by 2 minus 3t by 2 x square by 2 minus 3 by 2 x cube by 3 plus 3t x cube by 3, lower limit 0, upper limit 1. That is equal to 1 minus 3t by 2 minus 3 by 4 plus 3t by 2 minus 3s into 1 by 2 minus 3t by 4 minus 1 by 2 plus t, which is equal to 1 by 4 plus 9st by 4 minus 3st. So k3 of st is equal to 1 by 4 minus 3st by 4, that is equal to 1 by 4 into 1 minus 3st, right? That is equal to 1 by 4 k1 of st. So proceeding like this, k4 of st is equal to 1 by 4 of k2 of st, etc, etc. In general, kn of st, which is equal to 1 by 4 of k n minus 2 of st, right? k4 is k2, right? k3 is k1. So difference is 2, that is why n minus 2. So resolvent kernel is, so substituting the values, right? Summation m is equal to 1 to infinite lambda power m minus 1 k m of s comma t. So put m is equal to 1 2 3, so and write it in the summation and substitute the value of k1 of s comma t, k2 of s comma t, etc, etc, right? So we will get k1 of s comma t plus lambda into k2 of s comma t plus lambda square by 4 into k1 of s comma t plus lambda cube by 4 into k2 of s comma t plus etc, etc. So k1 of s comma t into 1 plus next lambda by 4, lambda power 4 by 16 plus etc, etc, plus taking lambda k2 of st from those terms. Second term, fourth term are with k2 of st, lambda k2 of st. First term, third term are k1 of st terms, right? So lambda k2 of st into 1 plus lambda square by 4 plus lambda power 4 by 16 plus etc, etc. So these two are common. 1 plus lambda square by 2 plus lambda power 4 by 16 plus etc, etc is common in both terms. Take it outside. So 1 plus lambda square by 4 plus lambda square by 4 the whole square. Lambda power 4 by 16 can be written as lambda square by 4 the whole square, right? Into k1 of s comma t plus lambda k2 of s comma t. So this is equal to 1 plus lambda square by 4 plus lambda square by 4 the whole square plus etc, etc into 1 minus 3 st, right? Plus lambda into 1 minus 3 by 2 s plus t plus 3 st, right? So substituting the value of k1 of st and k2 of st. So that is equal to 1 minus lambda square by 4 whole power minus 1. So this expansion, put x is equal to lambda square by 4. So 1 plus x square plus etc, etc can be written as 1 minus x whole power minus 1. So instead of x you are having lambda square by 4. So 1 minus lambda square by 4 whole power minus 1. Remaining terms 1 plus lambda minus 3 lambda of s plus t into s plus t by 2 minus 3 st into 1 minus lambda. So resolvent kernel gamma is given by 4 into taking LCM and group that. So 4 into 1 plus lambda minus 3 lambda into s plus t by 2 minus 3st into 1 minus lambda. So numerator, so denominator, because 1 minus lambda square by 4 whole power minus 1, taking LCM and take it to denominator, that 4 will come to the numerator, right? Then remaining in the denominator 4 minus lambda square. Thanks.